Hello all, what we see in this image is basically a soil sensor circuit. A very simple circuit, nothing complex about it. It basically revolves around the soil sensor. So when we say soil sensor, basically it is the moisture which is sensed by the sensor. So if you see this red PCB with two leads in between, this is a soil moisture sensor. So why do we need this circuit? So before going into the details of the circuit, let us see why we need this circuit. So let us assume you have a small garden and generally you water plants, right? So when you water plants, you might sometimes be giving lot of water unintentionally, or sometimes lesser water, which might lead to plants dying. So you might not be aware that there isn't enough water or there is too much of water. So in such scenarios, these kind of sensors helps to understand what is the kind of moisture that is present in the soil, and then water your circuit accordingly. So there are many ways here. This soil sensor reading can be used to do a digital display of the amount of moisture. The output of the sensor can be used to give to a small buzzer kind of arrangement, which we have done here to indicate that there is enough moisture. So once the functionality, basically the circuit that we put here is when moisture reaches a certain level, the buzzer starts horn. So in that scenario, the user can stop, or the gardener can stop watering the plants. So this also can be used in IoT applications where you have a remote farm and then you want to control the watering by controlling the motor. You can also do that. So there are several applications. So for this simple circuit, what we have taken is basically, as we said, a soil sensor is definitely required. The output of the soil sensor is connected to an LM741 op amp, which acts as a comparator. Okay, so this is the LM741 op amp, the black IC in the right corner, and then the output of this comparator is provided to a BC547 NPN transistor, which further horns the buzzer. So very simple circuit, and then this entire circuit is powered by using the power supply. So let us start the circuit from start to the end. So the circuit is basically powered by a supply of 12 volts, and then the 12 volts is fed to LM7805 CV, which is a linear regulator which produces fixed 5 volts. So we need 5 volts here because the soil sensor works on 5 volts. So that is why the supply is provided to 7805, and then the 5 volts, the output of this LM7805, as you see, is connected to the supply of this soil sensor. So to the input of 7805, we have a 0.33 microfarad which is recommended by the vendor. As you see in the left top, this is the recommended circuit. So we have a 0.33 microfarad at the input of 7805, and at the output we have a 0.1 microfarad ceramic capacitor that is connected. And once this soil sensor is given 5 volts, this sensor, based on the moisture, starts giving the analog output. That means it starts, to put it in OS terms, it starts giving out some, you can use a multimeter to see some voltage on the output of this sensor. So as the moisture increases, the analog voltage output increases. So now this analog can be given to a microcontroller and then read by the microcontroller, and further functionality can be done. But here what we did is we used the LM741 op amp, which we have used as a comparator. So if you see the right top of this image, this is the LM741 pinout, and then this is the simple connectivity wise diagram. So if you see here, to the non-inverting terminal we have connected a soil moisture sensor. So if you follow the circuit, soil moisture sensor output, which is a blue wire, through 1K resistor we connected to the LM741 op amp, and then again this is connected to the non-inverting terminal, and to the inverting terminal there is a reference voltage that is provided. So the reference voltage is generated by a simple resistor divider, which is formed by 1 kilo ohm and 10K pot, and the supply to this resistor divider is again from 12 volts, and this is given to the inverting terminal of the op amp. So how it functions is, first of all we'll adjust this pot and give a specific reference voltage at the inverting terminal of this op amp, and then we will insert this sensor into some soil and start watering. At specific point, what happens is this inverting terminal non-inverting terminal voltage, that is at terminal 3, that means the output of the sensor reaches the voltage, the reference voltage, and then because the non-inverting input is equal to or greater than the inverting input, the output becomes high. So till that point the output of this LM741 op amp will be low. Once this goes high, the output of this LM741 op amp is connected to BC741 base through a 1K resistor, and the output of this BC741 transistor is connected to a buzzer. So now again to explain the same functionality, when the soil moisture output is less than the reference voltage, the output of this comparator would be low, and when the output of this soil moisture sensor increases beyond the reference voltage, the output of this op amp goes high. So once this goes high, the BC741 transistor starts functioning and the buzzer would go. So this is how the simple functionality at the output of the comparator looks like. And then, as we understood, this is basically a analog sensor, and if you see the sensor, so this sensor what we are talking about is from SparkFun. So SparkFun has this available at $5.95 and you can get it easily from them, and there is stock available as well, and a very useful sensor and very good sensor for hobbyists to learn lot of things. So there are many ways to implement this circuit, as we explained. Use a microcontroller, use a IoT kind of scenarios, or use a LED kind of, or connect the output to a simple motor instead of through a relay instead of a buzzer, so that automatic turn off of the switch happens. You can control a valve. There are several things that can be done at the output. At the input, instead of power supply, if you don't have a power supply, you can use a wall adapter to take 5 volts directly instead of LM7805 and power this sensor, and also 9 volts batteries that are available. So very different combinations that can be used. Hope we try to give you some synopsis of the circuitry. Please let us know if you have any questions. Please post your comments. Please like and subscribe our channel. Thank you.